Hello, welcome to the GATE 2021 Ce Set 2 question number 41, which states that a rectangular cross-section of reinforced concrete beam is shown in the following figure. The diameter of reinforcement bar is equals to 16 mm. The value of elasticity of concrete and steel is given. We need to find the value of x for the uncracked section from the location of neutral axis or centroidal axis. Okay. This topic is based on the NPTEL course of Design of Reinforced Concrete Structures taught by Professor Indang of IIT Kharagpur. So let's see some basics first. Let us just start with the concept of modular ratio. So if we see the basic definition of modular ratio, that is M is equals to the ratio of elasticity of the material that we need to convert with respect to the elasticity of material that we are converting into. Okay, so this is the basic definition of modular ratio. So for example, in this case, the modular ratio will be elasticity of steel with respect to elasticity of concrete, because we will try to change or transform the steel into the concrete, or I should say the equivalent concrete. Okay, basically what I'm trying to say is that suppose you have the concrete here of width B sandwiched between two steel bars. So we have this steel bar over here, and let's say its width is A and this is also A. So we know that in order to find the location of neutral axis, we need to convert the whole section into a particular material or same material. So let's say if we want to convert this steel into concrete, we just need to multiply it by modular ratio. And since we are converting steel to concrete, so our modular ratio will be ES over EC. So how our final structure will look like? We have the initial concrete of width B, and now the steel will be converted to concrete 2. So this will become M times A, and this will also become M times A. So now this whole section became of the same material. So this is concrete. Okay, so this is for the case when steel is converted to concrete, and suppose the inverse happen, means if we want to change the concrete into the steel, then our modular ratio will also be changed. So in this case, M will be equals to what it will be? It will be elasticity of concrete, because we are changing concrete into steel, right? So elasticity of concrete with respect to elasticity of steel. We are changing concrete to the material of steel. So after the transformation, how our cross section will look like? It will be A, that it was initial steel. So the steel section will remain same, the initial one, and only change we will have the concrete will be converted to the steel. So it will be multiplied by modular ratio. And since we know that elasticity of steel is greater than the elasticity of concrete, so here when we are changing from steel to concrete, the modular ratio will be greater than 1. Thus you can see there is an increase in width, whereas in this case the modular ratio is less than 1 from here. Thus there is a decrease in width. So I guess this clears the concept of modular ratio. Also one more thing, from where this formula usually came? It's from the strain compatibility equation. Okay, what is it? Strain in steel at this particular point is equals to strain in concrete. From here you can put formula for strain, which is stress with respect to elasticity, similarly for concrete, and from here stress in steel will be equals to ES over EC multiplied by sigma C, and here it is our modular ratio, which shows the stress in steel will be greater than the stress in concrete at that point. Okay. Also, before moving toward the solution, we need to understand one more concept, is that in order to find the depth of neutral axis, we need to know the area of concrete, the area of steel at the cross section. So if we see the area of concrete from this diagram, it will look like this, where width is 200 mm and the depth is 350 mm. Note, this whole cross section is of concrete, but in the given figure at this area we don't have concrete, right? We have steel there, so we need to remove the concrete from there. So how much area it is? It is equivalent to area of the steel or cross sectional area of the steel. So we will subtract concrete area like this from this particular section, which is equivalent to area of steel, and this will give us the actual cross section area of the concrete, right? So let me draw it clearly in the next page. So this will give us the concrete of this much area. Okay, you need to note this area is not filled. Okay, this is hollow. So initially our concrete was full, we subtracted this area, we got our actual concrete. And since I told you in the starting that in order to find the depth of neutral axis, we need to convert the steel into the concrete, right? So we need to convert that. So how we will convert that? We will convert it by multiplying the modular ratio. So equivalent area of concrete at that particular location will be equals to m times of AST. So here we need to also add the equivalent area of concrete, so it will be plus m times of AST. So for the simplification, let us say we have these two as a one cross section for that particular point, right? So it will be m times of AST minus AST, which will is equals to m minus 1 times of AST, and our final structure will have something look like this. So this is your m minus 1 AST, and this is your whole area of concrete. Now we have all the things required to find the depth of the neutral axis. So let us just note down the given values. We have the elasticity of steel, we have the elasticity of concrete given in the question itself, which is 2.1 into 10 to the power 5, and this is 2 into 10 to the power 4. Let me use a different color for that. Now that's better. We also given the diameter of reinforcement bar. The diameter of steel is equals to 16 mm. From here we can find the area of steel. So let us just quickly find the parameters, which is modular ratio, which is elasticity of steel with respect to elasticity of concrete. Because we are changing steel into concrete, it will be equals to 2.1 into 10 to the power 5 with respect to 2 into 10 to the power 4. This will give the value of 10.5. Similarly, area of steel will be is equals to pi d square by 4 multiplied by number of bars, which is 3. It will be equals to 603.20 mm square. Now to find the centroidal axis or neutral axis location, we'll choose one reference axis from where we need to calculate it. So let us suppose we'll calculate the neutral axis from the top. So this is our reference line. All the measurement will be due from here. Okay, so the neutral axis can be found using the formula of weighted average. So a times of y bar is equals to a1 y1 plus a2 y2 plus a3 y3. Since we have only two areas here, one is concrete and one is steel, we'll use a into y bar is equals to area of concrete multiplied by the CG of concrete plus area of steel multiplied by the CG of steel from the reference line. Okay, let us just quickly write down the values of all the area. So area of concrete will be equals to 200 times 350. Neutral axis depth from the reference line for the concrete is equals to d by 2, which is 350 by 2. For the steel, the area of steel will be equals to 603.20. We already calculated before, and the depth of neutral axis of the steel from the reference point is this, right? So this is 350 minus 35, which is 350 minus 35. This gives us 315 mm. So if we write our final formula for y bar will be equals to AC times YC, and since we already converted the steel into concrete, So our equivalent area will be m minus 1 times of AST times YST divided by AC plus m minus 1 multiplied by AST. So this is your A1, whole this thing is your A2, and this is your total area. By plugging in all the values, we'll get y bar equal to 185.59 mm. Here we got the depth of the neutral axis. So we got the depth of neutral axis, that is y bar. In order to find the value of x, we just need to subtract y bar from the 315 mm depth, and ultimately we'll get our answer. So let us just directly do that. So x is equals to 315 minus y bar, which gives us the value of 129.41 mm. Okay, after plugging in y bar from here. And this solves our question. Thank you and keep learning.